Hello, my students. Today we are going to cover the Excel part of chapter number 28. So let us start. In the very first problem, we know the initial investment is $100 and the interest rate per year is 10%. So here we need to calculate the beginning amount, simple interest, compound interest, total interest, and ending amount for the next 5 years. So let us start. So first we're gonna put the initial investment for year number 1. It is $100. Now, in this particular problem, we are making just one single investment, and then we are gonna calculate the future value or ending amount of this $100 in the next 5 years. If you think this is the number line, then here in year number 0, we started with $100. Now we want to know the value of this $100 at the end of year number 1, then at the end of year number 2, then at the end of year number 3, then at the end of year number 4, then at the end of year number 5. All right, then let us start. So the formula we are going to use to calculate the value of this $100 at the end of 1 year from now, 2 years from now, 3 years from now, 4 years from now, and 5 years from now is the future value, FV. Now, to solve this problem, we need to know our periodic rate. And then in this case, your interest rate compounds per year. So your unit of time here is year. Accordingly, your periodic rate is also 10%. So 10%, then N par. Your N par here is just 1 because you want to know the value of this $100 1 year from now. So total number of time period you have here is year 1 times number of periods per year, which is also 1, equal to 1. Then PMT, here you don't have any periodic payment. You started with a lump sum amount of $100. So your PMT is 0. Then PV. PV is the lump sum amount you started with. So here your PV is $100. Now we are going to put negative PV. And then why we put negative PV here? Remember, if you want to get something positive in the future, you need to pay something at present. Likewise, if you want to get something positive at present, you need to pay something in the future. So whenever you pay something, it is your cash outflow, and your cash outflow should be negative because you are losing money. On the other hand, your cash inflow is something you are getting to your pocket. So it should be something positive. Now, here we want to make our future value positive. That means we want to assume that we are going to get something in the future. So it will be our cash inflow. Now, therefore, if we want to get future value to be positive, then our present value must be negative because we need to pay right now to get some positive value sometime in the future. Yeah. So let me also write down how I get rate here. Rate, annual rate, the number of periods per year, In this case, your annual rate is 10%. And as I said, here your interest rate compounds annually. So unit of time here is annual. So how many annual period you have per year? One annual period per year. So 1 equal to 10%. Likewise, N per is what? Total number of periods per year. So it is years times number of periods per year. So whenever we are calculating future value in year number 1, then we have just 1 year within this time period, and the number of periods per year as usual is 1. So total number of time period is 1. So now we know the future value here right after year number 1, it is $110. Now let us calculate future value at the end of year number 2. We're gonna follow that exact same process. FB rate, again rate should be 10%. Next, N per, this time you have how many time periods from year number 0 to year number 2? You have in total 2 years. As you can see here, in total you have now 2 years. Okay, so in total here you now have 2 years, and then number of time period per year is 1. So 2 times 1 equal to 2. So rate 10%. Then total number of time periods is 2. You don't have any PMT. Then you PV as usual, negative $100. Close the bracket. You got your future value. So your future value at the end of year number 2 is $121. Let's move on to year number 3. So you rate number of time period 3, then PMT 0. Your present value is negative $100. So $133. 10 cent. Next, FB rate N per, then PMT, then PV. So your future value at the end of year number 4 is $146.41. Next, future value at the end of year number 5, rate and per PMT, then your PV or initial investment. So your future value at the end of year number 5 is $161.05. All right. So now we know our future value in all the 5 years time period we have here. Now we want to fill up the column for the beginning amount. So the beginning amount of year, so the ending amount of year number 1 should be the beginning amount of year number 2. Likewise, the ending amount of year number 2 should be the beginning amount of year number 3, and so on. So you close the account for a particular year, and then with that amount you start a new year. So this is the concept. All right, so beginning amount of year number 2 is the ending amount of year number 1. Beginning amount of year number 3 is the ending amount of year number 2. Beginning amount of year number 4 is the ending amount of year number 3. Then beginning amount of year number 5 is the ending amount of year number 4. All right. Now let us calculate total interest we earned. So here you can see we started with $100 in year number one, and we end up with $110. And remember, in between this time period, that means in between 0 to 1, here you have never added any money from your pocket. So how come your money have grown from $100 to $110? Yes, the only way it is possible is that you earn some interest. And then what is that interest amount? That is the difference between the beginning amount and the ending amount. So you started with $100, you end up with $110. So the gap, $10, is your total interest. Likewise, you started year number one with $110 and you end up with $121. So the gap here between the beginning amount and the ending amount is your total interest earned during year number two, which is how much? $11, and so on. So let us start. So our total interest in year number one is the ending amount minus beginning amount. Then again, 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 ending amount minus beginning amount. So now we know our total interest. Let us now calculate simple interest. So what is the simple interest here? So simple interest is the interest you earn over your principal amount. So you don't receive any interest over your accumulated interest. Now, in this particular problem, what is your principal amount? Just $100. You have never added any money outside of this $100 to your account over the time period. So your principal has always been $100. So let us now apply interest rate over your principal only to get your simple interest. Okay, so here your principal is $100 and then your interest rate is 10%. Again, your principal is $100 and then your interest is 10%. So now we know our simple interest and we also know our total interest. And compound interest is what? It is the interest on your accumulated interest. So total interest is the sum of simple interest and compound interest. So the compound interest then should be the difference between total interest and simple interest. So total interest minus simple interest. Again, 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 total interest minus simple interest. All right. So now we know our simple interest we earned. We know our total interest on interest we earned over the time period. We also know total interest income we have. So let us now calculate total simple interest we earn over the next 5 years. $50. Your total compound interest or interest on interest is $11.05. Your total interest income is $61.05. All right. So let us start our next problem. DCF. So here we know our periodic cash flows from year number 1 to year number 5. We also know our interest rate. And again, this interest is annual interest rate. And as you know, if nothing otherwise stated, then we should assume that this interest rate will compound annually. So here, our unit of time is what? Annual. All right. So now in the very first problem, we are going to calculate the future value of these cash flows. First, let us copy all the cash flow information from our question. Now, let us identify for how many years we are going to get interest for each of our cash flows. Now you can see here, you deposited this $10,000 at the end of year number 1, and you are going to withdraw this money at the end of year number 5. Now the question is that for how many years you should get interest on your $10,000 deposit at the end of year number 1. So you are going to get interest from year number 1 to year number 2, 1 year. Then you're going to get interest on this amount from year number 2 to year number 3, second year. Then you're going to get interest on this amount from year number 3 to 4, third year. Then you're going to get interest on this amount from year number 4 to 5. So it is year number 4. So in total, on top of this $10,000 deposit at the end of year number 1, you are going to get interest for in total 4 years. In other words, it is the difference between year number 5 and the year when you deposited this money. Is it clear? Okay. So let me just show you the same calculation for the amount you deposited at the end of year number 2. So you deposited this money at the end of year number 2, and you are going to withdraw this money again at the end of year number 5. So you are going to get interest on top of this amount for how many years? Or in total 3 years. The same way, you're going to receive interest on top of this amount for how many years? For 2 years. For this one, you're going to get interest for 1 year. For this amount, you're going to get interest for 0 years. All right. So let us plug in all of this information. So here, you're going to get interest for 4 years. You're going to get interest for this one for 3 years. And then for the very last payment, you're going to get interest for how many years? For 0 years. All right. So let us now calculate our compounding factor. So you know the compounding factor formula is 1 plus your periodic interest rate R to the power total number of time period you have. All right. So here we all know our interest rate is how much? Our interest rate, periodic interest rate is 9%. Then to the power total number of time period. So we are going to use the exact same formula for the other 4 years. As you can see here, 1 plus your periodic interest rate to the power number of time period. All right. Now we are going to calculate future value of each of these cash flows individually. And then future value here is your cash flow times compounding factor. Right? Okay. So equal compounding factor times your cash flows. Cash flows times, sorry, let me just fix it. Some cash flows times compounding factor. Now we know future value of each of these cash flows at the end of year number 5. Now we want to calculate our total future value. So you're going to sum up the future value of the individual cash flows. All right. Now let us move to our next problem. In our next problem, we are going to calculate present value of our cash flows. Now, before we start, let us just copy the cash flow information from our question. Now we are going to calculate our discount factor. All right. First of all, what do you mean by present value? Present value means the value of a future cash flow right now. Now you can see here, you're going to receive this $10,000 at the end of year number 1. And you want to know the value of this $10,000 right now in year number 0. So how many times you want to, for how many periods you want to discount this $10,000? You want to take this money, the value of this money from year number 1 to year number 0. So what is the time gap here? 1. So you want to discount this $10,000 for just 1 year. Likewise, you're going to receive this $15,000 at the end of year number 2. And you want to take the value of this $15,000 from the end of year number 2 to the year number 0. So what is the time gap between 0 to 2? 2. So you have to discount this $15,000 for how many periods? For 2 periods. Likewise, you want to discount the cash flow you're going to receive at the end of year number 3 for 3 periods. You want to discount the cash flows you're going to receive at the end of year number 4 for how many periods? For 4 periods. Same way, you want to discount the cash flow you're going to receive at the end of year number 5 for how many periods? For 5 periods. All right. So first, let me just show you the formula for the discount factor. It is 1 over 1 plus your interest rate to the power time period. Okay, so equal 1 over 1 plus your discount rate, periodic discount rate, remember, to the power time period. As you can see, 1 over 1 plus your periodic discount rate to the power time period. All right. Now let us calculate present value of our individual cash flows. And let me just show you the formula. So it is cash flow times discount factor equal cash flows times discount factor. So now we know present value of our individual cash flows. Now let us calculate our total present value. present value of all of these cash flows right now is 47,528. All right. Now let's move on to our next Excel sheet. So here in the very first problem, you own a lottery, and based on the following assumptions, what is the present value and future value of your winnings? So here you can see we are gonna receive $100,000 over the next 25 years. So the payment frequency is here annual. Therefore, our unit of time is also annual. Interest rate here is 11%. So it is our annual interest rate. Okay. Before we proceed, let us find out our periodic rate. So rate equal to our annual rate times number of periods per year. So here our time frequency is what? Annual, because we are going to get annual payment. So number of annual period per year is how many? 1. So our rate, periodic rate is here 11%. Now next one is NPAR. So how many total years we have during our investment period? 25. Next, how many periods we have per year? 1. So our total number of periods is 25. All right. So now we are ready to apply present value and future value formula to calculate our present value and future value of all of these payments. Okay. So like I said, if you want to get something positive at present, you need to pay something in the future. Likewise, if you want to get something positive in the future, you need to pay something right now or over some particular time period. Now, here I want to get my present value and future value positive. In order to do so, I need to make my payments I'm going to use to get this present value and future value negative. Because remember, once again, if you want to get something positive right now, you need to pay something in the future or over a particular time period. Same way, if you want to get something positive in the future, then you need to pay something over a particular time period or at present. So PV rate, this is our periodic rate, and then NPAR, then PMT. We don't have any future value. Future value means here lump sum amount. We did not pay any one-time lump sum amount, right? So this is our present value, then future value. Again, rate, NPAR, negative payment. We don't have any lump sum present value. So now we know our present value and future value. All right, let's move on to our next problem. Suppose you are buying a house with the following terms. What is the monthly mortgage amount? Okay, so here your purchase price is $175,000. Number of months over which you're going to repay your loan is 240 months. Interest rate compounded monthly is 6%. So here you can see your payment frequency is what? Monthly. So your unit of time here is month. So number of months you have per year is how many? 12. All right. So keep it in mind, and then let us calculate our rate. So here, So here our rate is equal to our annual rate 6%, the number of periods per year. So how many number of periods per year we have? 12. Now if you calculate, then it will be 0.5%. Next, NPAR. NPAR means number of months in our investment horizon. In this case, it is already provided 240. Right. So now first let us calculate our monthly interest. It is 6% divided by 12. Next, we are going to calculate our monthly payment. So the formula is PMT. So we need to know our periodic rate, and our periodic rate here is 0.5%, and par, and then our present value. Let's make it negative, and then future value positive. Now you may ask why I made the present value negative. Once again, here I want to calculate my payment to be positive. So in order to, again, I paid some, so you need to have some cash outflow at present to get some cash inflow in the future. So if you consider yourself as a mortgager, then basically you pay the loan. You provide the loan. So you provide the money at present, right now, today. So it is your cash outflow. Then your borrower will repay you the loan in equal installment over 240 months in the future. So all of your future payments will be positive because you're going to get those money. Okay, so the monthly payment here is $1,253. All right, next one. Suppose you are saving for retirement and know how much you will save every year, as well as target retirement balance. What is the interest rate is, what interest rate is necessary for you to reach your goal? Okay, so now here we are gonna calculate our annual interest rate. So here, your retirement goal is $1.5 million, and then you are gonna pay annually $3,000. So here, this $3,000 is your cash outflow because you are gonna pay this money, cash outflow, and then this one is your cash inflow. And here again, you are gonna pay annually. So your unit of time is annual. Therefore, your NPAR is equal to total number of years times number of annual period per year. It is 1. Equal rate, then NPAR, then negative cash flows, then PV, and you don't have any lump sum future value. So 0. Okay, let me calculate one more time. Rate, so number of time period, and then your PMT, and then your present value, and then your future value. Oh, so this is your retirement goal. So this is the amount you want to get sometime in the future. So this is your future value. Remember, because it is your retirement goal and you're going to retire sometime in the future. So let us now solve. rate again, NPAR, your PMT, you don't have any lump sum present value. So 0 and then future value. So interest rate is 12.62%. All right. Next, you ran a little short on spring break. So you charged on your credit card with the following assumptions. How long will it take for you to pay off your credit card? So you owe $1,000 and then you are gonna pay $20 per month. So your payment frequency is month. Therefore, total number of months per year is 12. All right. And then monthly interest rate. So here interest rate is already converted into monthly. So it is your rate. So your rate should be your monthly interest rate and it is already provided. You don't need to break down annual interest rate or APR into monthly interest rate. Okay. So number of months to pay off this loan and par, then your periodic interest rate, in this case monthly interest rate, then you are gonna pay how much? You're gonna pay $20. And then you already spent $1,000. So this is the money you got right now. It is your present value. And you got this money, so it should be positive. And then you are not paying anything lump sum in the future, or don't get anything lump sum in the future. So it is 0. So your NPAR is 93.11. And here, remember, we are using monthly information to calculate NPAR. So the NPAR we get here is also total number of months. Now we want to know total number of years. So divide total number of months by the number of months we have in a year. Then you get the total number of years to pay off your credit card loan. And in this case, it is 7.76 years. All right, let's move on to the next problem. So in our next problem, we are going to calculate effective annual rate. All right. So effective annual rate, the formula here should be effect. Then you need to first put your nominal interest rate. So nominal interest rate here is 12%, or your annual percentage rate, same thing, APR is 12%. And then number of time periods per year. So whenever your interest rate compounds semi-annually, then total number of time periods you have per year is 2. So if your interest rate here compounds semi-annually, then your effective annual rate is 12.36%. Same way. If your interest rate compounds quarterly, then total number of time periods per year you have is 4. Then your effective annual rate is 12.55%. Then if your interest rate compounds monthly, then your effective annual rate is 12.68%. If your interest rate compounds daily, then your effective annual rate is 12.75%. So as you can see here, the higher the frequency, compounding frequency, the higher the effective annual rate. Why? Because the higher the interest you earn on the accumulated interest.